Hello there! Good day, everyone! I am Arnel Trevero, and I am together with my partner, Saira Mela Bininay, and we are going to discuss the proofs of the Pythagorean Theorem. First is, we are going to prove it using manipulative ways, and the second one is the formal proof. So Pythagorean Theorem states that in a right triangle, the sum of the squares of its legs is equal to the square of its hypotenuse.
Hi, this is Sarah May Labininay, and I'm going to show you the proof of the Pythagorean theorem using manipulative device. In showing the proof of the Pythagorean theorem using manipulative device, we need to have three squares. So we have here the first square, which is square A. And the size of these squares is what we call the small letter A. So here, all of this measures A. And as we remember, the area of a square is equal to A equals S squared. So therefore, the area of this square is equal to A squared. Next, we have a small square which is B. The size of this square is equal to B. So the area of this square is equal to B squared. And lastly, the third square. So the size of this square is C. So therefore, the area of this square is equal to C squared. Okay, before we're going to prove the theorem, first we need to divide this square. After putting this line, we have to cut those lines. After cutting the first square, we will put this to the square which has the area equals C squared. Okay, after putting those things to the big square, we now have this one as a result. So as you can see, the two squares which having the area A squared equal to A squared and B squared fit to the square that we made, which is equal to C squared. So therefore, when you add the two square, A squared plus B squared is equal to C squared. And that is how we prove the Pythagorean theorem using the manipulative device.
Hello again, it's me, Arnel, and I am here to prove the formal proof of Pythagorean theorem. But before that, let us first recall some of the basic mathematical concepts that I will be using in this proof. First is we have the area of a trapezoid is equal to 1/2 times its height times the base 1 and the base 2. Next is we have the area of a triangle, which is equal to 1/2 times its base times its height. The next one is we have the sum of the angles of a triangle is 180 degrees. Then the sum of the angles of a straight line is 180 degrees. And now, we are going to draw the triangles and start proving the Pythagorean theorem.
It's unbelievable.
Let us first have this triangle. We have here this triangle and label its side as A, B, and this is C, and having this vertex there as the right triangle. And now we are going to label the angles of this triangle. So we have here the right triangle. If we are going to label this angle here as theta, we are going to have the angle here as 90 minus theta. It's because the sum of its angles should be equal to 180, and having 90 minus theta plus 90 is equal to 180.
This is as good as it gets. It's unbelievable. Don't know what's gonna happen next. It's unbelievable.
Next is we are going to draw congruent triangle to this one to its adjacent side.
You haven't seen nothing yet. It's unbelievable. It's unbelievable. When I was a kid, I saved up all my dough so I could.
Now, we are going to label the other triangle. So we have here, this is A, since that is the smallest side. Next is this will be B, and this one is C. This is a right triangle. Next is we have the angle theta, which is supposed to be here. Then this is 90 minus theta. Next is we are going to connect this point here and this one.
3PO, put Mentos in my Diet Coke in the backseat of the bus.
There you go. Then let's try to check this angle here. So we have there the sum of the angles of a straight line is equal to 180 degrees, and this one here is a straight line. So that would mean that theta plus this one, 90 minus theta plus this angle here, this one, that one is equal to 180 degrees, right?
Then you could join the club. When I was a kid, I spent my Saturdays blowing on Nintendo games. The newest thing was Lion King, and I could feel the love. It's unbelievable.
That means to say that this unknown angle is equal to 90 degrees. Now, try to look at the new formed polygon. Can you identify what polygon is that? That's right. It's a trapezoid. So the area of a trapezoid is equal to 1/2 times its height times the base 1 plus the base 2. Now, we are going to prove, or we are going to find the area of this trapezoid. You have here 1/2 times its height. Its height is A here plus B. So we will have A plus B. Next is we are going to multiply it to its the sum of its base 1 and base 2. So we have base 1 is equal to A plus the base 2 is equal to this one, B. And the area of this whole trapezoid is equal to the areas of these 3 triangles, right? So we are going to equate it to the areas of these 3 triangles. Let us first have the area of this triangle here. We'll be having the area of a triangle is equal to 1/2 base times height, so we'll have 1/2. The base is B times the height, which is A. That's right. Next is we are going to add the next triangle, this one. That will be 1/2 times the base, which is A, and its height is B. Next is the third triangle, this one. We'll be having 1/2 times its base is C times its height is C. Well, we can simply write that as C squared, right? Since it is C times C. And now, we are going to simplify those terms above. We'll have 1/2 A plus B times A plus B is equal to A plus B quantity squared equals, by commutative property of multiplication, BA can be written as AB. So 1/2 AB plus 1/2 AB is equal to AB. We'll have AB plus this one, 1/2 C squared. And now we are going to simplify A plus B squared further. We will have 1/2 A plus B times itself, which is A plus B. We will have a squared plus 2ab plus b squared is equal to, just copy that side. And now, we are going to distribute 1/2 to this whole term here. We will have 1/2 a squared plus 1/2 times 2ab, that will be 2 times 1, that is 2, divided by 2, so 1. We'll have ab plus 1/2 b squared is equal to, just copy the terms. Next is, we are going to multiply all the things there by 2 such that 1/2 will be eliminated. So we'll have, let's multiply the whole term by 2. This will be 1/2 times 2, that is a squared there, plus 2 times ab, we'll have 2ab, plus 2 times 1/2, that is 1, so we'll have b squared, equals, that is 2ab plus 2 times 1/2, that is 1, so we'll have c squared. And now, we are going to use addition property of equality such that we will be able to eliminate 2ab from both sides. We'll have, add both sides by negative 2ab. We'll have negative 2ab. That will be 0. This is 0. We will have a squared plus b squared, which is equal to c squared. And that is the Pythagorean theorem.